Okay, on the back here now, everything that came out of the radicals on the front page, that's not going to happen anymore. Notice we're going to get something like the square root of 50 that can be simplified, but not everything's going to come out. There's going to be some things that move out front, some things that stay inside, and then they want you to verify with an approximate answer. So remember that this thing up here was called the exact answer, the simplified radical, and this down here with the bumps was done on a calculator as the approximate answer. We'll go over the approximate answers in class, but here I'm just going to go over the simplifying of the radicals. And that way, when you have the calculator in class, we'll double check that you were able to get these correct. So part C is root 18. What times what times what equals 18? Maybe you think of 2 and 9, 3 and 6. Keep going till you're to the smallest parts. Now we're in a square root, so we look for groups of 2. A3 comes out. A2 stays in. In a minute in class, we're going to go ahead and do the approximate answer. If you want to put the plus or minus on these, feel free, but we're looking just to see if you can break these down. Root 20, maybe you think of 2 and 10, maybe you think of 4 and 5, but keep going until it's down to its smallest parts. A2 comes out, A5 stays in. We'll get the approximate answer in class. Next, it's asking you to rewrite using exponents. So for example, x times x times x could be rewritten as x to the third. Y times y is y squared. This becomes a to the third on top, b to the third on the bottom. This becomes 3 to the fourth, 2 to the fourth. This becomes 2 to the fourth, 5 to the fourth. Simplifying, this is reminding us of the add rule. So that 4 plus 3, c to the 5 plus 2 plus 2 is going to be c to the 9th. This becomes 5 to the negative 7 if I add or combine those, which becomes 1 over 5 to the 7th. Don't forget to move that downstairs. This one becomes 5 minus 4 is 1. 1 minus 1 is actually x to the 0 power, and anything to the power of 0 is just, you got it, 1. Who thought it was 0? Okay, next one's the multiply rule, g to the negative 8, because you're doing 4 times little negative 2. And the negative exponents want to move, so it becomes 1 over positive g to the 8th. 5 stays up top. E to the negative third moves down. D to the negative 10 moves up. This becomes 2 to the negative 5th, x to the negative 5th, like shower your power. So this becomes 1 over 2 to the 5th and x to the 5th, which could be also written as 1 over 32, x to the 5th, if you want to. Next one is negative 3 to the 4th power and d to the 4th power. So this becomes 81, d to the 4th. This one's got a negative 5 coefficient, but this needs to first be stretched out. Oh, I hate how 2's look like z's. 3 times first. So 2 times 2 times 2 is 8, z to the 3rd. And then that negative 5 is out front. So final answer is negative 40, z to the 3rd. How'd you do? Over here, k to the 9th stays up top, but k to the negative 10th wants to move up. And then I can do the add rule for my final answer of k to the 19th. You could have also done this problem as the subtract rule. You know, there's a couple alternations. So 2 to the 15th, 2 to the 12th. This is going to be the subtract rule, which becomes 2 to the 3rd, or just 8. Remember, we're subtracting the exponent on top minus the exponent on the bottom. Everything gets the power of 5 here. So this becomes negative 243, f to the 15th, g to the 5th. This next one was very much like the one on the test, except there wasn't a negative exponent. 2 to the 3rd, t to the 2 times 3, 5 to the 3rd, over s to the 4 times 3. And so this becomes 8. 2 to the 3rd is 8, over 125, t to the 6th over s to the 12th. How'd you do? And the 8 and the 125 can't simplify, so we just leave it. This becomes m to the negative 28 over n to the negative 12, q to the negative 20. Because of those negative exponents, everything wants to flip. N to the 12th goes on top, q to the 20th goes on top, m to the 28th flips to the bottom. Next one is just 10 times 9 is 90. X squared and x is x to the 3rd. Y to the 3rd, y to the 8th is y to the 11th. There's no weirdness on that one. You're just multiplying the like things. Next one's a negative 2, g to the 4th, h to the 6th. That one wasn't bad. And finally, x to the 3 times negative 2, y to the negative 2, x to the 4 times 2, y to the 3 times 2. Now we're going to do the add rule. It becomes x to the 0, and then y to the 4th, which means it's really just 1 times y to the 4th. Final answer. Next one, see how the 24 and the 18, a number can go in? And so what goes into 24 and 18? A 6. So 4 goes in, 6 goes in 4 times, 6 goes in 3 times. Subtract rule, 8 minus 3 is w to the 5th. Subtract rule, 7 minus 5 is z squared. What goes into 8 and 12 here? 4 goes in 2 times, 4 goes in 3 times. There are 3 more a's on the bottom. There is 1 more b on the bottom. There is 9 more c's on the bottom. That one looks weird with just a 2 on top, but there you go. Finally, I've got 1 p up top, 3 p's on the bottom, so you've got p squared on the bottom. Q to the negative 4 minus 2 is going to end up being q to the negative 6 with the subtract rule. And since it's a negative exponent, it's going to want to move downstairs. Q. Okay, hang on. Sorry. This is going to be q to the negative 4 minus 2. Oh, that is what I did. Sorry. And then that moves downstairs. And then finally, r over r is just 1. So we're done.